All right, part 2, we're going to approximate the square root of 115 to the nearest tenth. At the end of part 1, we approximated the nearest whole number was 11. And I'll just refresh your memory because I need to refresh my memory. 11 is on the high side. So our little scratch chart is going to work down because any 11 point anything is too high. Okay. So I'm going to maybe start with 11.7. You don't have to. Hopefully you've already done this one. You might still be a little bit confused, and that's okay. But I'm going to just start with 11.7 and see where I end up. Now, unfortunately, we are getting into triple digit multiplication. I'm sorry, but you do have to know how to do this. So I'll work it with you, okay? 71120 Okay. Now we got to add all this up. 2 decimal points. Okay. Makes sense. So I'm going to pencil in up here 1, 3, 6. Oh, notice I'm way too high. You know what I just did? Y'all are probably sitting there laughing at me. I just told you that 11 point anything is too high, and then I worked out 11.7. So while my answer makes sense in my multiplication, I know I didn't make any errors there, I don't think. It doesn't make any sense. I just did extra multiplication, okay? So I'm going to clear all this off, and maybe I'll go grab a tissue and wipe my tears off for extra multiplication. So we'll try again. So 10.9 is the highest that it can be. I should have attempted 10.7, which is what I'm going to do now. 10.7 squared. I'm going to just do 2 zeros and come over here. All right, 9, 4, 4, 1, 1, 2 decimal points. So 10.7 squared is 114.49. All right. Wow. I'm just going to tell you, there is no way we're going to get closer than 51 hundredths away from 115. So I hit the nail on the head. That helps make up for that extra multiplication I just did. So, to the nearest tenth would be 10.7. All right, that's how you approximate. That's another example of approximating to the nearest tenth. I am going to skip over Guided Practice 5. It just uses the same formula from example 3. I do want to talk about 2 things. You might remember when we were at school together that we did this chart at the bottom. We talked about whole numbers and then integers being the next circle out in a Venn diagram, basically. And then rational numbers and irrational numbers. So, and that all of those fall under the head category of real numbers. So just remind yourself of that information at the bottom of 583, because I have a feeling a question will come up in homework like, what's a rational number? What's irrational? Perfect squares are rational numbers because, I am sorry, this handwriting is terrible. It's because I have so much trouble with this whiteboard. Rational numbers is this third circle out. Okay, and actually, perfect squares fit into the integer category because the square root of 16 is plus or minus 4. So it's either a whole number or it's a negative integer. But imperfect squares, like the square root of 17, because I'll say the square root of 115 because we just did that. Okay, we are approximating that it is 10.7. Okay, a decimal would fall under rational numbers, but not, this is rounded. If you did use a calculator and you typed in the square root of 115, it would fill out the screen with numbers because it's irrational. It's non-terminating, and you might remember that we talked about non-terminating decimals before. So this number right here would fall into a separate category of irrational numbers, and then both rational and irrational fall under real numbers. And there are imaginary numbers, but that's a high school category, so we're not talking about those. All right, let me clear this off. Okay, I'm going to skip over into some of the homework problems because I'm hoping to not do a part 3 to this video, and I only have about 10 minutes left. Again, if this is confusing, if you need me to go through it with you more, I'll be happy to FaceTime with you. Just send me an email. All right, I have notes written in my book after I went through this lesson last week, and one note that I told myself to tell you is that you might end up with an answer when you're approximating to the nearest tenth. And even if you do all the trial and error, you know, as we did on the other one, if I had picked 10.8 squared and then I picked 10.7 and saw that that was closer, you do need to do the work. You need to find out, you need to get within a tenth or a whole number of the answer here. Don't just make a guess because of what I'm about to say. But if, for example, in guided practice 4, if you worked it out and you came up with an answer within reason, you did the multiplication, and you put 10.7, and then you look in the back of the book and it says 10.8, don't worry about that. I'll give you a 1/10 slide either way when I grade your quiz, okay? And the reason I'm saying that is from number 39. So we are going to do that one here. It gives me an opportunity to kind of go over some other things. So this is how you solve number 39. Now, if you think you're up to it, solve it first and then come back and go through the solution with me to make sure that you did it correctly. It harkens back to 11.1 because you do have an equation to solve with the variable. So we're going to go through the same steps to get started by moving the constant first. And that gives us 34. Then we're going to divide both sides by 16. And that gives us x squared equals 2. Okay? And to get x alone, we find the square root of both sides. So here we go. The square root of 2 is not a perfect square, okay? So I have, and the directions say round to the nearest tenth, so that's what my approximation is. So I'm looking at these two perfect squares. I'm closer to 1, so I'm going to start at 1. I've got to figure out which to the 10th place squared is going to give me the closest to 2, okay? Now, I am going to start with 1.3 just because, okay? So 1.3 squared, and here's another little note I might have written somewhere. Remember how I told you to have that list of perfect squares? Well, on that list, you should have 13 squared, okay? And you should see that it's 169. So now I don't have to do long multiplication, okay? I just need to put my decimal point in there, okay? I think this is going to come up in 11.3 is where I've seen it, okay? So 13 squared, or 1.3, I'm sorry, is 169. So I'm getting closer to 2, but I'm not quite there, so I'm going to keep jumping up. I'm going to look on my list, and I'm going to see that 14 squared is 196, so I'm going to add a decimal point, and I'm getting super close. I have a feeling that 1.5 is going to go over because I know 15 squared is 225, okay? So here we are. This is the closest, okay? So I would say x equals 1.4, And this brings me to my point I made earlier. The back of the book says 1.5. Obviously, 1.4 is closer. So somewhere in the way they calculated it, I think they used a calculator. They got 1.5. It is probably because they worked them out like to the nearest hundredth, and I am not about to show you how to do that. I think that is way too much work. So you're brave souls just to go with me into the nearest tenths. So that's why I'm telling you, you might be a tenth off from the back of the book. All right, I'm going to try to cover one more before the video ends. And that's number 43. I have a feeling I assigned this for homework, so that's why I have a little note next to it. So I'll work it out with you. If you've stuck with me this long, you might as well get a little help on number 43 because it's hard. To find out how fast a car was going before an accident, investigators can use the equation S equals, and we've kind of done one of these before, the square root of 30 df. So we're going to have some variables we have to substitute numbers for, where S is the speed of the car, D is the distance or the length, and F is the coefficient of friction. Don't let that freak you out. You're just going to plug in what you know, okay? It says to find the speed of the car. So we are going to have S as the variable that we are solving for. So I'm going to go ahead and plug in what I know. D, our distance, is find the speed of a car that left an 85 foot. So there's our distance. And this coefficient of friction is 0.5. Okay. So, order of operations says I need to work inside this grouping symbol of a radical sign. And the commutative property says I can multiply in any way that I want. So, I'm going to give you this little shortcut. 30 times 0.5, or half of 30, is 15. So, I just need to work out 85 times 15. And I get the square root of 1275, okay? So I look over at my perfect squares that I have listed out, and the highest one I have is 600. Now, this is why I'm going over this with you. You don't know a squared number that gets up that high. So you do have to do a little bit of trial and error. Oh, I'm sorry, I gave you the wrong number on this. It's 625. Okay, you do have to do a little bit of trial and error, all right? So again, little guessing. It does say round to the nearest whole number, so I'm going to show you a little bit of approximation to the nearest whole number. I'm going to jump up to 30 squared because I can do that one pretty easily. I know it's 900 because 3 squared is 9, okay? And that covered about 300, so I'm going to try for 33 squared, okay? I'm just trying to get as close to 1275 as I can. So we have 99099, and that gives us 1089, so I'm getting closer. Let me try 34. 1156. Okay, I'm guessing it's going to be 35. And if you're following along with me, hopefully you're checking my math, but you won't have to do all this long division. You can kind of know, oh yeah, she landed on 35. 1225. Okay, I'm not going to get closer because you can see I'm jumping up at least 75 each time. So, I would say it is approximately 35 miles per hour. The book answer is 36. So let's just quickly see. Again, I told you you can be one off, okay? So that would be 21, 0, 18, 0, 6, 9, 2, 1. Oh, that is closer. Okay. So I would accept either answer, but that's why the book says 36. All right. I went through that really quickly. Again, if you are confused, please let me know.